All right, our next presenter is Michael Kane, not to be confused with Sir Michael Kane. He is going to talk about the Chumstick Liberation Front, restoring passage and plants. Michael Kane is a restoration ecologist with a focus on whole watershed restoration. His natural resource career started a long, long time ago on a prescribed burning crew with the U.S. Forest Service and included many seasons on managing trails and wilderness in Lake Chelan and Leavenworth districts. After completing a BS at Huxley College of Environmental Studies, Mike began working as a field forester and a wildlife and wetland biologist for private consulting firms. About 20 years back, he decided to shift into restoration and has been working on stream, wetland, and forest restoration ever since. In recent years, he has been coordinating large-scale forest health restoration projects, along with restoring floodplains and fish access to streams in Chelan County. So I'll let you take it from here, Mike.
Great, thanks. Thanks, Drew. Thanks again, Heather. Can you guys hear me okay?
Yeah.
Excellent. So, yeah, thanks for the introduction and the opportunity to speak at the symposium. This is, I'm going to talk a little bit about a project we started a number of years ago in the Chumstick Valley and try and develop a kind of a list of lessons that we learned from it and in order to share with you all. The focus was on this valley that's north of Leavenworth, and here in the topo map you can kind of see that there's a lot of private land running up this drainage just north of Leavenworth, Washington. And it's a very large overall watershed, but kind of a smaller creek, more of like a spring-fed creek, and it's not really draining off the east slopes of the Cascades, so it has kind of an early season runoff, and historically was probably more just a product of the beavers and their activities than anything else. There was a lot of low-grade habitat in here, and so when people settled in this area, they of course put in lots of driveways off the highway across the creek, and now we have a lot of barriers. In this image, I've shown that the top left quarter you can kind of barely see Lake Wenatchee, and on the right you can kind of see the Columbia River. And the white arrow kind of left to center is pointing to this drainage, the main stem Chumstick Creek. And you can see all those green dots. This is from the Washington Department of Fish and Wildlife barrier portal. And what it shows is that most of those barriers have been fixed at this time. There's one or two that are left. There's some further upstream. And you can see to the south of that arrow, there is a large drainage that's called Eagle Creek, which is the Chelan County Natural Resource Department has started working on. So it started back, my involvement in it started back in 2008, working for the Chelan County Natural Resource Department on their staff. Currently, I'm still working with them as a consultant and on a number of different projects. But at the time, this was a fairly large project that got started for us with the help of Vulnerable Power Administration funding. And this image here just gives you an idea of kind of the direction things were going back in the 50s. You can see the bridge in the background, nice bridge spanning the creek. This is only a quarter mile up from the confluence with the Wenatchee River, kind of around river mile 19 or 20 on the Wenatchee. And they're replacing it with a culvert. They're installing that culvert there. And effectively that culvert kept steelhead out of the system for a number of years. It provided access in some years. Steelhead could make it up through that culvert to get further upstream, but in most years it was a barrier, fish passage barrier to steelhead and other species. And the focus, Chumstick Creek is a smaller creek, so most of the focus here is for steelhead and coho access. Chinook did get up into the lower couple of miles, and I'm not sure I understand that picture. So it was pretty bad up there. There was a lot of barriers spread throughout the drainage, and then in some places, these are mostly culverts. There were some irrigation ditches, but in some places, the actual beavers would come in and plug up the culverts because you basically had a levee spanning the floodplain, and then the beavers could plug the culverts, and then even the humans couldn't get home, couldn't get to their places. So Chumstick was in pretty bad shape, and with the funding from Vulnerable Power Administration, the county got started in 2008 on a fairly large effort to remove about 22 barrier culverts and 4 irrigation diversions on the main stem to open up about 9.5 miles of coho habitat. And it took about 5 years to get through all those, and 5 years later, barriers had been removed, and we had fish passage up through here. We started detecting steelhead in this area, and then we learned a few lessons along the way. This is an area up about river mile 7.8. I'll have a couple of images from it later on. You can kind of see there's a series of rock weirs that were constructed. It's vary in size, kind of similar to what Reed was talking about. Our first effort in here was really to get passage, and since then we've been back to the landowners to talk about kind of reestablishing floodplain connection, but that hasn't been a focus of theirs. But I'll talk a little more about that when I get to this one. I just wanted to go through and talk a little bit about some of these lessons that we learned. The first thing, always acknowledge partners in your project. This is a large-scale effort that took many years and lots of funding. Fortunately, we had good base funding from Bonneville Power Administration to get started on the project, so we actually had a contract with Bonneville to fund the design and construction of 12 replacement bridges to replace for these culverts. We were able to up that to 17 culverts the first year, and then the Chelan County Public Works Department was replacing that North Road culvert at the same time. So in the very first year of construction, 2009, we actually replaced, I think we replaced 17 culverts and 1 we removed altogether. The Bureau of Reclamation was also a great partner, both financially and providing technical assistance. Same with U.S. Fish and Wildlife Service. They helped a lot with the initial surveys. The survey had initially been done in the 90s on this drainage to assess passage. And so while we were addressing the culverts, we had to go back out and rewalk some of the sections that hadn't been allowed to have access in the previous survey. So we actually found more barriers while we were in the process of removing the ones that we already knew about. Yakima Nation came in and had funding to fund, I think, 4 of the culvert replacements. And then the Chelan County Natural Resource Department staff was coordinating and managing the overall project throughout this effort. We came in later to the Salmon Recovery Funding Board to get additional funding to help with some of the upstream barriers that were discovered. And then I think it's important to mention that the property owners were a pretty key partner. There was a number of years where folks weren't really supportive in this area in general. There were definitely some supportive members, and there was even a Chumstick Watershed Council at one time that was focused on this work. And a lot of the work that those folks had the groundwork that they had laid, including Natural Resource Conservation Service and the Cascadia Conservation District, that had kind of provided some groundwork for this work that we were able to come in and do later. But the one thing I really wanted to focus on, because I think we found there was a lot of interesting uses, some of the tools that are out there. So as far as lessons, number 2 is try new stuff. And we had not seen this wetland sod or sedge mats before, and we were exposed to it from North Fork Native Plants. This is a kind of a plug for them. As you can see, they're out of Driggs, Idaho, and they grow this stuff, and it's really pretty amazing erosion control material to work with. These come in about 1 meter wide by about 5 meter long, and it's a coir mat that's thick, and it has sedges grown in it to develop the root mass, and you install it during the growing season. They're heavy, so they do take some effort. You can get a variety of mixes in there, and these are the 2 that we found worked really well for stabilizing the edges, excuse me, on some of our projects. They have others that are more inundated for more of the year, and these ones are kind of in a wet, dry type area, so they definitely dry out in the late summer in this case. And if you want to collect your own material, whether you're doing plugs, sedge type plugs, or having them grow the coir mats, you just need to add some more planting time. This bottom image here shows the custom mix grown from site collected. And so you're looking at, they're going to need a couple of years to grow that out after you send them the seed. And then, and again, that gets installed during the growing season. So I just want to take you through kind of a little bit of a case study to show kind of how this stuff can be used and how we used it in this case. This is an irrigation diversion that was identified when we were surveying in between culverts we had already built. So we had built these culverts and then we found this diversion in between, and it turned out to be a complete barrier. It's kind of an outfall drop onto a slab. So steelhead really weren't getting past this point at that time. And the landowner really liked the feature because it reminded her of growing up on a farm, and she liked the gurgle noise. So it took a lot of work to kind of bring the landowner on board to be supportive of the project. But finally, we were able to do that. And this project commenced, and as you can see here, we're out with the excavator starting to remove that irrigation diversion. And I just wanted to show a few slides, not focusing so much on the construction side of it, but really on the planting side. And then we built weirs in this case. She was looking, I mean, we could have probably focused on a roughened channel or something like that, but we decided to go with a more aesthetic kind of design to get the landowner on board. And that really helped a lot with our effort in this case. And so here's the weirs under construction. And then once we had the weirs set down, we started going to work putting these sedge mats out. And I think I mentioned they're quite heavy. In this case, they're 100 to 150 pounds. So you don't want to try this with a small crew, bring some friends. It happened to be raining the day we were installing these, and that's actually great. That's probably some of the best conditions you could have. You want to keep these things moist. You don't want to, a lot of times if we have to leave for the day, we just kick them into the stream if we've got it staked out so they can't disappear, and keep them good and wet. And then once you've rolled them out, you have to prep the site a little bit, make sure that you got good contact with dirt. If you try and put these on just solid rock, they're not really going to take hold. You need some kind of soil to root. So in this case, we went above the rock-lined weirs and graded out a little area where we could get this into soil contact. And then we staked them very well with angled stakes to kind of hold them down. So what you're getting is you're getting this sort of instant growing mat that provides this erosion control. And you do it during the growing season. You want to get at least 3 to 4 weeks of growth out of these things before dormancy. And that can be challenging because you're often coming in after construction, which is often in August. And so it's hot and it's dry. So once you put these in, you're committed to having someone out there watering them periodically until it starts raining in October or whenever that is. You just don't want to let them dry out too much. And the other thing that's interesting about this, because they're so heavy and large, getting them delivered can be tricky. So in some cases, they bring it in on a semi-truck. So you got to figure out just logistically how you're going to get that semi into the site, turned around, kind of exposed. This is just that same site. We're looking at the fall planting in this case. And in this site, we used a lot of local stakes. There was quite a bit of adjacent material that we could use for the site. And you can kind of see we've got the drawdown for short-term erosion control. And then I just got a couple of shots post-project. This is, we had a big flow in the winter right after this project was installed, but I don't have a picture of that, but it was even higher than this. This is a typical spring flow. Chumstick Creek being a little more east, it comes off earlier than a lot of the main stem rivers. And so this is a pretty high flow in early April. And you can see that it's got some velocity moving through there. And once that flow dropped, you could see, this is late April, you can kind of see the edges of those small sedge mats along there. There were a couple that weren't staked well at the upstream edge, so they had folded up about a foot, but they had been installed early enough that the roots had grown in and sort of taken hold. And the way we were using the sedge mats was really as a kind of a short-term erosion control measure. We live staked these things pretty solidly through this area in this site, so we knew that we were going to get a lot of vegetative growth from the shrub layer, and it eventually would gate out a lot of these sedges. And then this shows you kind of the next year's growth at that site, and I think I got maybe one more. And then this, of course, is a couple years later, 2013. And if I tried to take this picture today, you would just see a wall of brush because the trees are, 25, 30 feet tall. But in this case, working with a landowner, she liked the gurgle, she liked the sound of the old dam, and so we provided her with these weirs that provided fish passage and gave the landowner a good feature on her landscape. This is very close to the house, by the way, so I didn't have an image showing their cabin, but it's only about 40 feet from the cabin, the edge of the creek. And then there was upstream of that, there was this other case, and I really enjoyed Reed's presentation and some of the things he talked about. And this image here from 2011 kind of shows some of the things he was talking about. You can see in the upstream portion, which is down at the bottom of the photo, there's a nice meandering creek kind of moving down through there. There's a little orchard on the right bank, and then you hit there's a big turn, and there's kind of a ponded area and then a long straight stretch. And I think what had happened was this area had previously been meandering. There was a flood in the 70s, a pretty big flood in this area that caused an avulsion through here, or not, excuse me, an avulsion, but a head cut through here. And my guess is that this was a lot of old vine deposited sediments behind beaver dams, and it just cut a deep channel down through there. So the landowner had come back years later, and not too many years later after the flood, and built man-made dams, 3 of them throughout this thing, just to sort of, not unlike the sort of idea that we use and we talked about with BDAs or the post-assisted log structures. He was trying to reestablish that sort of sub-irrigation, bring the water up to sub-irrigate his crops in this area. In this case, it's hay. And then you can see that the shift from the meandering section to the straight reach is really abrupt through here. That's quite an example of this. I would say this is the highest pear orchard in the valley, and this image is also kind of helpful. I'm going to talk a little bit about fire and fire hazards. This is a kind of an interesting image to think about with regard to that. A lot of landowners are cautious about having a lot of trees go into their planting sites and different types of trees, and I'll talk a little more about that as well. Here's a picture. This is kind of that bottom of that ponded area there, and you can kind of see on the right the waterfall, which is the man-made diversion, or the man-made dam, which created a passage barrier for fish, and at the same time it did maintain that water table up high. And our main focus with the project initially, of course, was just to reestablish fish passage through this area. We might, if we were doing the same project today, we might take a stronger stance and try and grade from the bottom up and approach it the way that, similar to what Reed was talking about. But in this case, the landowners have been resistant to that approach. We did bring it up at the time, but we realized we weren't going to get very far. So the interesting thing here, a couple of notes, is one is you can see the ubiquitous reed canary grass throughout the site. There's this large slow water ponded area, and we knew that this was going to be kind of a problem once we dropped this grade. We didn't want to create too big of a head cut through here, and this is kind of what started happening once we started construction. We started removing the barrier downstream. We had this thick layer of silt that has been deposited over many years. This drainage has a reputation for having a lot of silt transported. And again, you can kind of see the canary grass there on the margins, very heavily influenced by canary grass. And again, we showed up with the sedge mats because really have any other tool. You could barely even walk out there, but what we ended up doing was using the sedge mats to stabilize that material and create this channel, define the channel, and then stake them well, and then use live stakes with willow and dogwood to kind of secure that whole thing. It was like working on a fellow for a little while until it stabilized. And it shows you an image afterwards, and you can still see that canary grass. This is in the early spring. It's a great time to go out and look at sites, because especially with canary grass, because it's so hard to see when you're there in late summer and the canary grass is high. But this gives you a sense of the density of willow plantings in this area, and the focus on overplanting, really kind of similar to what Reed had responded to the question earlier. I think the literature often talks about putting in live willow stakes on a 1-foot center for treating canary grass, and that's a lot of willow stakes. In this case, we used willow stakes, but we also used plant material as well. So I just wanted to give you this sort of overview. This is from Google Earth, and fortunately there was an image from 2011 and 2013 to kind of show you a before and after of the project site in that spot I was just pointing to. 2011, you can kind of see it's still ponded there. There's the waterfall the dam downstream that I mentioned before that's maintaining that ponded area. Very shallow, very prone to warming, not really a good scenario. And then the post project, you can kind of see that channel that we sort of locked in there a little bit, trying to stabilize that sediment and silt, and then the weirs traveling downstream, which were built to match that grade from down below in 2013. And you can just see the vegetation starting to take hold in the 2013 image on that sort of peninsula where the pond used to be. And then in 2015, this was an interesting image because it was taken in the fall, in the spring and May, and you can actually see the canary grass very clearly. It's that really light, dry color. So it's kind of a helpful thing if you're using Google Earth and there's a spring image, you can often pick out the canary grass problems beforehand. And in 2017, on the far right, you can see that now there's this really dense, thick forest, essentially, of willow and dogwood, and I think there's some cottonwood in there as well. And then, of course, the channel itself is pretty well shaded out by all the plantings in this area. This was that downstream area this is the start of the very straight reach, and farmed, intensively on both sides, hay farm, but great opportunity to get passage up through here. And then just one more sedge mat comment. This is one of the culvert replacements up in this area in the upper Chumstick, and how we use that kind of as that temporary erosion control all along there. And very, very effective in the short term, but it has to be handled carefully. It's expensive. There's logistics to getting it delivered at the right time, and then of course it is kind of labor intensive to install it. So besides using new tricks, I think number 3 is, make sure you use some of the old tricks that have been around a while. And bioengineering is a great opportunity. You're usually going to run into a landowner who has some sort of eroding bank issue if you're looking at a large area and you want to find ways to treat it kind of using a softer technique. In this case, in the image above, we're using a brush mattress with a willow wattle at the toe to sort of secure that slope. Doesn't look that pretty initially, but it eventually brushes in, and it provides a pretty good secure anchor for that slope. And then on the downstream image is the coir cloth. You've got an eroding bank that's very steep, and you sort of lay back the slopes and use the coir with the live stakes. These are all good techniques. There's been a lot of literature. Chris Hogue has written and probably presented at more riparian and stream restoration presentations than just about anybody on bioengineering. And don't be afraid to experiment and use different techniques and adaptations. It's a great thing to use. Even some of the work that Reed was talking about earlier, I mean, sometimes we'll put stakes, live stakes, into the channel itself just to start getting that process going if it's a small enough channel and you got a good chance of it rooting, you can help use that to grade small channels as well. There's a few rules about live stakes, and most folks are familiar with them, but I'll just touch on a couple because they are important. It's really key that you don't over-harvest from an individual plant and try and source your material locally as much as possible. Sometimes you'll actually find you're sourcing material from someone else's willow project from 20 years ago that was most likely imported from some other drainage, but that's part of some of these heavily altered environments. If you cut the stakes straight, not too curved, they're going to be a lot easier to get into the ground with a tight fit and a good contact with the soil around them. You don't want a lot of air pockets. I tend to cut the bottom of the stake at an angle and the top squared off, so that's how I remember to get them in right side up. Make sure you store them out of the sun, keep them moist. Generally, if you're soaking them prior to planting, if you've got a lot of dogwood, you want to mix it with willow as well and kind of get that willow water effect, which willow has a natural rooting hormone that helps a lot. And the form stake I mentioned here is something you just pick up at Home Depot or Lowe's, and it's essentially just a 2 to 3 foot long metal stake that's used to hold concrete forms up, and it's handy to pound that in for your pilot hole. It's a good thing to have. You buy a few at a time. 2/3 of the cutting in the ground, right side up, and again, back to what Reed had said about getting the stakes to contact with that moist layer. You really want to target the layer that's going to be moist in midsummer. That there's going to be there's a typical drought period that occurs in, if it dries out for September, October, that's usually not as big a deal, but you want the feet in the water the rest of the year. You really want the bulk of that growing season kept moist. These things will really take off. And then you need to have 3 buds above the ground just to ensure. If you're in canary grass, you might want to leave a little extra sticking out the top as well, because the canary grass is so aggressive, and it's just one of those pieces that you need to consider. So in this case, I wanted to include an example from a failed planting, and this was from the first round of culverts that were replaced with bridges. There's a kind of a higher bank, about 3 to 4 feet above the stream level at low flow, and what had happened was everything had pretty much died in this area. So this was back in 2011, and we used a post hole digger to dig down about 3 feet down to the water table and then get our plants down there. Using a longer material, 5 to 6 feet long, the local nursery would grow out. And generally, tree pots or deep pots are good for this. You can use smaller material as well. And if you do try this, a gas-powered auger is a real handy tool. And this is generally reserved for these sites where you don't really have the option to grade the water channel and bring it back up and do more of a natural process type restoration. Sometimes you're kind of forcing the site a little bit just to get cover, just to get that shade that you're looking for the stream and the project. And then someone sent this to me a couple of years ago from Fleener, probably at one of these, presented it probably at one of these symposiums. And this shows a good diagram kind of to explain that idea of getting down to that capillary fringe. And of course, depending on the type of material, whether it's a fine silt or sand, that fringe, it's going to wick moisture up from the water table a certain distance, and you're probably going to have to either use a soil probe or dig some holes to figure out what that elevation is to use this technique. But again, if you do get down to that water level, this could even be done during the growing season. It doesn't necessarily have to be done dormancy. It'll work either way. So number 5, I'm going to say, as Reed pointed out, there's a lot of opportunities to use LiDAR, and for years we didn't have it in the Chumstick, this upper portion of Chumstick Creek, but this can be extremely helpful for just figuring out what's going on the ground. Even sometimes you have old remnant ditches that run across these areas. left over from the farming days when they were trying to drain the wetlands. And they're tough when you find them when you're walking through the canary grass because they're often a couple feet lower than the surrounding terrain. And sometimes you can pick these things out with a LiDAR. In this case, this is up in Upper Eagle Creek. There was a, I was all confused when I was out there walking around, and then I came back and looked at the LiDAR and realized that the confusion was based on there was a channel, a section that had been channelized, so the creek was not on the left where it was supposed to be in the floodplain, it was on the right. So that let us know when we start working on this project that we want to look at an opportunity to get that creek back into that floodplain. So the LiDAR can provide all kinds of little tricks. Sometimes you can actually find barriers on the LiDAR that you wouldn't have found otherwise. And it's remarkable. You can also find, like in some of the historical record, you'll find a reference to a dam, and it's so hard to know where that thing is until, and especially if you don't have permission from the landowner to go out there. But then once you start looking at the LiDAR, those images usually show up fairly quickly. There's also landslides and other unstable slopes that can show up, and that's very helpful as well. In this case, wildfires is something that around, of course, the Leavenworth area and a lot of eastern Washington is very important to be thinking about. It not only affects our thoughts about the project site, but it can actually affect implementation of projects. Sometimes we get shut down during wildfire season for construction because of the high fire danger. But I think it's important to be thinking about landowners with regard to a lot of these projects in the Chumstick are close to homes. And so there's a large effort, there's a group of folks who are committed to reducing fuels in these forests and trying to find ways to sort of fire escape their homes and survive wildfire. So if you create a corridor of vegetation that's going to carry fire, that could create a little bit of a problem. So I wanted to talk a little bit about that. There's a lot of literature around homes and out there that best thing is probably to get a hold of a local group that maybe is working on this. Like there's fire protection groups and local fire districts, and they can answer your questions usually. And just thinking about, typically our shrubbery vegetation is going to be dense around streams and wetlands. Sometimes you got more of a sedge type environment, but oftentimes we're planting the shrubby, sort of pioneering type species. And once we're out of that corridor and we get into more of the upland area, thinking in terms of a forest or meadow community is really helpful, especially if you're not on a north slope where you have a denser vegetation. And generally with the ponderosa pine and Douglas fir, you're in these upland sites, you're going to try to use more of a clumps and individual and opening mosaic planting pattern rather than just a thick, solid vegetation corridor with 200 trees per acre. Some of the south-facing slopes, when you have mature trees in the Leavenworth area, we're looking at as low as 35 trees per acre that we're shooting for managing, just with this sort of configuration, in a clumps of individuals and openings pattern. So that's something to keep in mind. There's, like I said, there's a lot of literature about it. Homeowners are going to be specific. They'll usually tell you what they're thinking about. I think that sometimes folks want a screen. They want a privacy screen, and so they want things planted heavier. But in general, people have gotten a memo at this point that it's not good to plant too much vegetation too close to your house. I wanted to throw this image out there also, just thinking on those terms. This is kind of both for looking at reed canary grass, but also in terms of just the overall sort of function of some of these wetlands. This is just a little further up the Chumstick Valley. It turns up into Mary Canyon, and you can kind of see this is from that 2015 Google Earth image. There's a lot of reed canary grass out in this wet area, and it shows up quite readily. And there's a thin rivulet, which is not the creek. That's actually a ditch running through there that you can kind of see in the image. And in this case, we're working now with these landowners on either a post-assisted or a BDA type project through this area. And they're very interested in seeing ponded water in a raised water table in this case, partially for the just the security that it provides in a fire-prone landscape to have a really wet area very close by. And so this is a great opportunity and a great way to interact with landowners and restore floodplains and be thinking about what could we do that's actually going to enhance the area, both for wildlife and visual aesthetics, but also for kind of that functionality during big fire seasons and fire events. And in this case, the creek is kind of jammed up against the hillside at the bottom of the frame. You can see the heavy vegetation. Another thing that's interesting about this location is that in looking at the LiDAR, I was able to discern that there was an old railroad grade that came up into this drainage. And kind of turn of the century, I think 1900s, they had a small railroad grade that came up through here and was used for logging. It was basically just a logging railroad. And so that's another aspect of LiDAR, is that you can kind of help alert, once you get to know a site pretty well, you can kind of help alert folks like who are looking at cultural resources and stuff as to what's out there, things that you need to kind of keep in mind. And then again, this kind of kicks off the canary grass lesson, which I think all of us have, who have done planting projects, have had our share of frustrations with canary grass. So my first thing is, if you're doing any kind of a barrier replacement project, then you're fortunate, because then you're going to tear it up with the excavator while you're building your project. So that's a really helpful place to start. Even beyond the disturbance that you do for your project, you can do a little bit of sod removal with the excavator with a bucket, and a skilled operator can do that, and that gives you a much better planting medium, gives you a place to start. And then again, similar to what I said earlier, and I think others have said as well, is the dense planting is really going to help you get to where you want to be. You really want to get that very thick, unless you're moving towards an emergent type wetland, then that's a little different, and that's a different take. And in that case, you may want to be really focused on flooding out the canary grass. But there's, like Reed had said, the first step is going to be looking at the overall site and up and downstream and what the possibilities are. If you're planting on a bench adjacent to the channel and you're outside of that flood zone, you could use cardboard as well. I think there's a lot of examples people have used of cardboard. It's very labor intensive and it can be very effective. Probably not as good to use in the floodplain where it's prone to frequent inundation. But then if you do use cardboard, like a lot of things, make sure you mulch the heck out of it after you do. And it's best to put the cardboard down on a wet surface. If it's really dry, you'll try and help the moisture in. But that doesn't apply necessarily to canary grass, but more upland type sites. And then if you don't have an excavator, you're going to have to sharpen your shovel or get some crew with weed eaters and metal blades and get them out there working, because canary grass takes a concentrated effort over a long period of time. And then I think this is a piece that's especially important for me as a kind of a lesson learned and a continue to learn is just the way that you work with the landowners and the neighbors. For one, they need to be comfortable with what you're putting in, and oftentimes people have problems with specific plants like cottonwood, for example. People don't like the fluff, or they don't want it anywhere near where their branches are going to break off and fall into their farm field over the long term. In some cases, if you're around orchards, there's concerns about airflow. If you plant too thick and too tall of vegetation, they don't want a forest where it's going to disrupt the airflow. And then there's other species that are also, people have certain allergies to things, so just trying to check in with the landowners and see if there's anything they really don't want. Sometimes, a lot of times, they'll say, well, I really would like to have this, and that's something you can help gain their respect and involvement. And then one thing I've learned is, especially in the Chumstick, we tried to get a lot of the neighbors to consolidate driveways, because we were replacing a culvert, and then we were going about 150 to 200 feet up the stream and literally replacing another culvert. And we were trying to figure out if we could get, you know, a shared agreement on a road and just have one, you know, consolidate and save a bunch of money and effort. We did not succeed in doing that in the Chumstick. They, landowners, there was often so much animosity that between neighbors that we found we couldn't really do that. And I think also people just want to secure their access to their home. So you want to try to get coordination that way if possible. And if you're lucky enough that you find some existing problem that you can solve, that's great. That's a great win. And again, the thing about the landowners, especially the ones who've been there a long time, is there's a lot of opportunities to learn from them. If I'm bringing an engineer out to a site, I'll often ask the landowner, you know, to join us and answer questions about big flows that they've seen and different conditions and how the river has changed over time. And that's often a really good source of information for designers and engineers. And then it's also just to have them out walking on the ground with you and helping you understand what's going on with their property and what their concerns are. And that really helps because a lot of this is going to hinge on that and, you know, how they use their land and how your project is going to affect that use or not affect it. And then when something doesn't work, you know, you just need to come back and fix it, and they need to be able to count on you. I mean, I know in cases I've been back multiple times when an irrigation screen, diversion screen wasn't working properly, and it was kind of a learning process just to realize exactly how it was installed. So I was jumping in the creek and getting that thing moved around, and I think the landowner appreciated that. I think that's part of your job out there, is to really work with the landowners and find some ground that really works for everybody. I think one of the big takeaways in this case from working in the Chumstick main stem was, even though we were coordinating a large-scale project, we were very focused on fish passage and, of course, the restoration of the riparian communities after we had disturbed the site. And as we move into the Eagle Creek drainage, which I had pointed out before, we learned a few things since then that if we can design clusters of projects at the same time, there are other opportunities that are going to allow for more of a reach-based restoration approach. So, for example, if homes and such are well out of the floodplain, there might be an opportunity to treat some of the incision that's common in these drainages, and especially at the same time that you're treating these series of barriers, replacing these culverts with bridges. And again, thinking about the fire risks and such, you also want to really enhance those floodplains wherever you can, and landowners are really starting to get this because they've seen the changes in the landscape over the years and the recurrence of the fires. So that's a good way to help encourage folks to look more holistically at restoring these drainages. And then just making sure that when the landowner calls and asks you to come out and take a look at something, that you're able to make your way out there and be available and be responsive. It's an important piece of this. So that's kind of what I had for you today. It's kind of a short little case study, but I wanted to just give you guys some ideas of some of the things that we've learned out there in the Chumstick. And if you've got any other questions, feel free to ask now. And also, if you think of something later, I've got an email address here at the bottom. Feel free to contact me. I think there's a learning curve with doing the riparian restoration projects, and it really is helpful to talk to different people about different approaches. And stepping back and trying to spend a little bit more time with the larger scale view and looking upstream and downstream is really going to be key for project success. And even understanding, like, historically, where were the beaver dams, if you can figure out on the landscape, where did they occur prior? There's lots of resources out there as well. Like, you can see the old USGS maps, and they'll show ponded areas that are no longer ponds, and it makes you realize there was probably a diversion there at one time. Most of these streams were pretty heavily dammed and diverted at one time, and now they're not as much, but there's still quite a bit of scarring out there on the land. So with that, if there's any questions.
Great, thanks, Mike.
Yeah.
We may not get to all the questions, but Mike, if we don't get to all the questions, you can actually go into the Q&A box and answer their questions directly. But we did have someone that asked you if you could show your slide 10 again.
Okay, let me see here.
Oh, great. And we'll make these slides available on the Recovery Board's website, on our symposium website, and we'll send that link out when that's available.
And then, just to be, this is actually an excerpt from that North Fork Natives website. So this information is available. They have a lot of information available on their website if you're interested in pursuing this further.
Great. Drew, did you want to take one of the questions?
Yeah.
And then
Yeah.
Okay.
Mike, could you share again where you sourced the sedge mats from, and if you have any other advice you'd like to offer on how and when to use them?
Yeah, the company is called North Fork Native Plants, and they're out of Driggs, Idaho. And I haven't checked lately to see if there's a local nursery that's taken up this type of thing, but it's a very specialized approach that they've taken on there. And so they've been doing it for a number of years and figured out a lot to it. And it's, as far as the, I'm sorry, what was the rest of the question? There was another piece to that, Drew.
Yeah, if you could just maybe give some advice on how and when to use them.
How and when, okay, yeah. So I think in our case, we really were emphasizing in this situation where we wanted erosion control. We just wanted to make sure, because we'd had some projects where they were essentially using large rock along the banks for erosion control, and we found that to be a very hard place to plant. It just really was a challenging way to do the project, and so we wanted to shift from a harder surface on the margins of these channels that we were having to rebuild these channels through where there had been culverts and we were replacing with bridges. So in that stream simulation, we wanted to use the coir kind of to help anchor the coir impregnated with the sedge to help anchor the banks. And seasonally, you want it in the growing season. You want to get it installed as quick as possible because you want it to start growing that first year of installation and start setting the roots down so that it's really held down throughout the surface. That's a crux piece. And I think if I go back, let me see if I can. Yeah, so here in this bottom table, it's in year 3, it says final grow to meet spec May through June, and then delivery June through September. So even in September, you can get growth in there, but the earlier into August you can get these things in the ground, the better off you are as far as getting them established. And again, this is one of a number of products that they use. They also, I haven't used these myself, but they also use coir logs, which they do a similar process where they impregnate with these sedge seeds and these sedge clumps, and so you can actually create these coir logs. And some people, if they have steep banks they're trying to build up, they can use that approach as well. It's kind of like a toe log kind of a thing